All right, so welcome back, everyone. We're going to be looking at hyperbolas this week, our last conic section. We've seen hyperbolas before. It's like where we have the two branches. But a hyperbola is a set of points such that the distance of the distances from any point on the hyperbola to two fixed points remains constant. These fixed points are called the foci points or our focus points. Um, you should see that this relationship between them has an equal distance. That's just the definition of a hyperbola in terms of a conic section. But as you've seen, it's just really where you have a branch here and you have a branch here. You can have two types. You can have a horizontal or a vertical. Some vocabulary. These, I'm going to do it for both of them. These red points would be your center. Since it's horizontal, the points to the right and left that are actually on your hyperbola itself, like the branches, these are called your vertices. Oops. So these blue points are my vertices. The points here, like on this box, are my co-vertices. And then these yellow points, like outside our branches, these are going to be like our focus points. And one thing to notice in this diagram, they draw like this dotted rectangle around the co-vertices and vertices. This is going to be useful to help us get our asymptotes, to kind of help us kind of when we draw our graph to see kind of what the branch is kind of contained between, kind of to make our graph a little bit more accurate. And you can see kind of similar on the vertical parabola or hyperbola. The points above and below, these would be your vertices. So it's kind of a little bit reverse of the horizontal. And then these points to the left and right would be your co-vertices. And these yellow points would be your focus points. So talking about this, the center is the midpoint. Turn the black. So it's equal, like it's right in the center between the two focus points. The asymptotes are diagonal lines that guide the curves. Like I said, they're just going to kind of help us get a more accurate graph of our hyperbola itself. The vertices, or the turning points as they're called, are plus or minus a units away from the center. The co-vertices are plus or minus b units from the center. We're going to see it's kind of similar to when we had ellipses. We'll see how you determine which denominator is your a or b, though is different than the ellipse, so we'll have to be a little bit careful about that. But the focus points are plus or minus c, and the formula to find your c is c squared equals a squared plus b squared, which I believe is different than when we did ellipses. We're going to have two formulas, one for our horizontal hyperbola, and we're going to have one for our vertical hyperbola. So this first formula, I'm going to put a little h here. This is going to be our horizontal. This is going to be our vertical formula. But our horizontal formula is going to be x minus h squared over a squared minus y minus k squared over b squared. Okay, let me actually rewrite this. They're in a little bit out of space. Oops. Let's try this again. I'm sorry about that. It's all good. So we're going to have for our horizontal, just sort of a little too big, it's going to be x minus h squared over a squared minus y minus k squared over b squared equals 1. So it's very similar to the ellipse formula, except there's a minus instead of a plus. For our vertical formula, it's going to be y minus k squared over a squared minus x minus h squared over b squared equals 1. And so it's a little sloppy. That's an a squared on the denominator there. One thing that's going to be important is notice that your a is always under the first fraction before the minus sign. So it's not necessarily like your a doesn't always have to be bigger than your b, like when we did the ellipses. So that's one thing we're going to want to be careful about. Equations of an asymptote. I'm going to have you guys not worry about this because when we draw that dotted rectangle in our graph, it's going to give us the asymptote. So I don't see a ton of value of getting the actual equation of the asymptote. But there is a formula, like if you are in a future class, maybe I'll mess with it then. But for what we're doing, it shouldn't really matter too much. But to graph a hyperbola, the first thing you want to make sure that they're in standard form. All the problems you'll have in your assignment today, they are. You want to find your center, and then use your A to get your vertices, use your B to get your co-vertices. And then we're just going to use, we should be able to draw in our box, get our asymptotes, and kind of sketch our hyperbola from there. So let's look at our first example. We're going to just do these problems 1 through 4. So our first one, the first thing you want to look at is what's your fraction, like what's your variable before the minus sign. Since it's x squared over 4 first, that means we're going to have a horizontal hyperbola since the x part came first. If you look at the formula, it's in the standard form of like the horizontal formula we had. So that means our a squared is going to be that first denominator. Our b squared is always the second one for hyperbolas. So our a is 2, our b is 3. Our center, you look at your numerator, you want to see if there's anything up top with our x and y part. Well, there isn't anything, so our center is just going to be 0, 0. Oops. So we can plot our center at 0, 0. And since it's horizontal, we're going to use our a value to go right to and left to, because whatever type you have, that's what you're going to use your a to go in that direction, and then your b goes in the unused direction. So if it's horizontal, your a tells you to go left or right, your b is going to tell you to go up and down. So we'll do our vertices in blue. So we're going to go right to, and we're going to go left to of the center. Our co-vertices I'll do in green. You're going to use your b value, so you're going to go from the center, you're going to go up 3 and down 3. So before we draw in our hyperbola, I'm actually going to just write the coordinates. So you can do look at your graph, or just think about how you're manipulating the center. So our vertices, though, we're at 2, 0, negative 2, 0. Our co-vertices were at 0, 3, 0, negative 3. And we'll worry about the focus points. Asymptotes we're not going to do. We'll do the focus points at the end. To actually sketch a graph, what you're going to do is you're going to draw a dotted rectangle around your vertices and co-vertices. You're going to draw, I'll try and use this ruler, you're going to draw diagonal lines, like asymptotes, so use like a dotted line that goes through the diagonals and the center of your rectangle. And then you're going to do the other diagonal. And try and make sure you go through the center and the diagonals. Let's see. It's probably pretty decent. Okay, put the ruler away. So it's a little sloppy, but when you draw your hyperbola, you always use your vertices. So those are those blue points. And the asymptotes just kind of help guide like how wide or kind of like how far up and down it's like how fast it increases. So that would be my first branch. And then my second branch is going to be guided by these asymptotes. So it should get really close to those diagonal lines we drew in. And if you wanted to, like there are formulas, you could actually get the equations of the asymptote, but like I said, not that important. So in terms of like our actual answer, like the blue branches up here would be our hyperbola. Like if you type this in the Desmos, you would just see what I have in blue on this graph. The other stuff's just gonna help guide us to get a more accurate picture. Like your center is not actually part of your graph, and your co-vertices are not actually part of your hyperbola. To get your focus points, you're just gonna use that formula. Oops, not the highlighter. You're gonna use that formula c squared equals a squared plus b squared. So that would be 4 plus 9, or 13. And if you square root 13, it's approximately 3.61. Since this is a horizontal asymptote, you're going to go 3.61 to the right, and you're going to go 3.61 to the left. So those yellow points I added to my graph would be my focus points. It's always going to be like inside your hyperbola, if that makes sense. Like it should be kind of contained within those branches. So our focus points would be 3.610 and negative 3.610. Okay, so that's our first example of a horizontal. Let's look at another one. So this equation, we have y squared over 36 minus x squared equals 1. Well, the first thing I notice is the y part comes first. So that means we're going to have a vertical hyperbola. So our a squared would be the first denominator. This is really over 1, so our b squared would be 1. So a is actually 6, b is 1. Our center, there's nothing up top on our numerators with the y and x, so it's just going to be 0, 0. So we can plot that. Since our hyperbola is a vertical hyperbola, we're going to use our a value to go up and down from the center. So we're going to go up 6. That would be at 0, 6. And we're going to go down 6. Oops, I'll do these in blue. So down 6. And then we're going to get our co-vertices, which I'll do in green. So since our b is 1, we're just going to go 1 to the right and 1 to the left. So if we want to write our coordinates, our vertices are at 0, 6, 0, negative 6. Our co-vertices, we're at 1, 0, negative 1, 0. So now we're ready to sketch our hyperbola. So you want to draw a dotted rectangle that goes through your co-vertices and vertices. Let's see, this one's going to be kind of rough, but let's see if we can do it. We're going to draw our hyperbola through our rectangle and through the center of the that we drew. So my first asymptote, I'll even do a solid line just so it's easier to see, but it really should be a dotted line because it's not actually going to be part of our graph, but I'm having trouble drawing a good dotted line on this. This would be our second asymptote. So to actually draw in our hyperbola, well, you look at your vertices, which are in blue. So that's this top point, and it's just guided by those asymptotes. But technically, like those black lines I drew in should be dotted lines because they're asymptotes. They're not actually part of the graph. But like I said, what's in blue would actually be what your graph is. Like if you type this in your graphing calculator, or if you type this in Desmos, you would get what I have in blue. Like you wouldn't see like those green co-vertices. You're not going to see that center point. Those points just kind of help you get your asymptotes, which let you get a more accurate picture of what your hyperbola will actually look like. Like I said, don't worry about your asymptotes, but to get your focus points, we can just use that formula. So c squared equals a squared plus b squared. So if you add 36 plus 1, that's just 37. And if you square root that, it's approximately 6.08. So since this is vertical, you're going to go up that 6.08. So it's going to be like so close to the vertices, like literally just 0.08 further away from it. But your focus points would really be 0, 6.08, 0, negative 6.08. So it's honestly kind of hard to sketch because it's going to be so close. Like this point actually, oh no, so what I wanted to do. This point, sorry, it was up 6. Just trying to fix it, but I think I just made it worse. It's going to be like so close to that original vertice. So it's kind of hard to sketch. So hopefully I didn't like throw you off too much with that, but what I had was correct. Just hard to plot those points because if you look at the focus points and the vertices, they're almost overlapping in terms of a graph this small with this scale. Okay, let's look at one where we don't have a center at 0, 0. Well, the first thing you should notice is that the x part comes first. So this is going to be another horizontal. So like more like the first one we saw. That means our a squared is our first denominator. B squared is going to be the second denominator. So a is 5, b is 4. You look at your numerator to get your center. So be careful, make sure you always do the x part first and then the y part, which it is in that order for this problem, but we'll see the next one, it's not. But our x part is 3, our y part is 2. Right and right. Okay, let me. Okay, to get our, so now we can start graphing. So our center's at 3, 2. Since our a value is 5 and we have a horizontal hyperbola, we're going to go to the right 5. We're going to go to the left 5. To get our covertices, we're going to go from the center up 4. And we're going to go down 4. So let's write these coordinates over here, and then we'll draw our rectangle and we'll draw our actual hyperbola. So our vertices, you could either look at your graph or kind of do kind of algebraically what you did to your center. Like, for example, we went right 5, so we'd really be adding 5 to our x value of our center, and we went left 5, so we would subtract 5 from the x value of our center. Our covertices, we went up 4 from the center, so it would be 3, 6, and we went down 4 from the center, so it would be 3, negative 2. Oops. Rewrite these, just kind of keep the color coding going. These were my green points. So like I said, that was 3, 6, and 3, negative 2. So now we're ready to draw in our rectangle. And we're going to use our ruler to try our best to draw our asymptotes. So I'm going to do a solid line just because it shows up a little bit better on the iPad. But technically, if you're doing it like on your paper, you really should use a dotted line. Because usually asymptotes, we never use solid lines, but desperate times call for desperate measures, eh? And remember, our blue points are actually part of our asymptote. So they're going to be guided by these, our hyperbola is going to be guided by these asymptotes. And you can see it's a really wide kind of graph. Okay, I was just checking the key just to make sure they didn't really draw this one in on the key, which is weird, but oh well. But that would be our graph for number 3. We just want to find our focus points. So using that formula, c squared equals a squared plus b squared. So that would just be 25 plus 16 is 41. Square root that, you're going to get c is approximately 6.4. So since this is horizontal, you would go 6.4 to the right, 6.4 to the left. Since our a was 5, that would mean you're just going to go over an extra 1.4. And you're going to go an extra 1.4 to the left, or you could just count 6.4 to the right and left of the center. So our focus points, though, if you either do it algebraically or just look at what you just plotted, our focus points were at 9.42, and they were at negative 3.42. And like I said, don't worry about actually getting the equations of our asymptotes. There are formulas, but usually just using that rectangle, I mean, lets you get your asymptotes. But to get an equation, you need to do a little bit of algebra. Looking at our last example for today, since our y part comes first, this is going to be a vertical hyperbola. Since our a squared is always the first fraction, our b is always the second fraction. Just remember, when we did ellipses, it was different. For the ellipse, your a was always the bigger denominator, your b was always the smaller. But for hyperbolas, it's just based on the order. So it is easy to kind of mix and match some things from the different types of conic sections, but that's how hyperbolas work. So our a would be 6, our b would be 3. Be careful, like I said earlier, your center, you might be tempted, you might write, oh, I think it's 3, -1, but remember, you always have to do the x part first, and then the y part, so it would actually be -1, 3. Very easy mistake to make. I actually made it myself earlier today, so it happens. But to graph this, we'll plot our center, so -1, 3. And now we can, since it's a vertical hyperbola, we can get our vertices. So we're going to go from the center, we're going to go up 6, 1 away from the top. We're going to go down 6, so it'd be 3 below the x-axis. To get our co-vertices, we're going to go right 3 from the center. Oops. And we're going to go left 3 from the center. So to write those coordinates, either look at your graph or make sure you're starting at our center. So you'd be, like, for example, we went up 6, so we would add 6 to the y value of our center and get 9. And we went down 6, so you would subtract and you would get -3. Our co-vertices, we went left 3, right 3. So if you went right 3, you'd get 2, 3. If you went left 3, you'd get -4, 3. So now we're ready to draw our rectangle, like around our vertices and co-vertices. And I'll pull out my ruler. Oops. Like I said, I'll do a saw line just because it just shows up a lot better. And this one would be something roughly like this. And remember, we always use our vertices. So our vertices are my blue points, so it would be guided by those asymptotes. And it would look something roughly like this. But we still need to find our focus points. Our focus points, remember using that formula, you add the a squared plus the b squared, so that would be 36 plus 9 is 45. If you square root that, it's approximately 6.71. Since this is a vertical hyperbola, you're going to go up that distance and down that distance. So our first one, it would almost be on the top of the graph. It'd be like 9.71. I can't really draw it in super accurate. This one going down 6.7. It'd be just like almost 1 square down below that vertex. The coordinates would be -1, 9.71, and the second coordinate would be, right, our second one would be -1, -3.71. Like I said, don't worry about finding the asymptotes. There is like a formula, but quite frankly, I mean, using the rectangle method, I mean, you're going to get your picture. So, I mean, unless you're doing something super specific where you need to know the equation of the asymptote, I don't see a ton of purpose, but there are algebraic ways to define for it. So that's it for this week. Hopefully these notes weren't too bad. Hopefully a little bit shorter, we'll see. But than yesterday's. But there is an assignment posted on Classroom for this week. It's for hyperbola questions, for parabola questions. Hopefully it's not too bad. Let me know if you have questions. Next week we will start our Desmos project. So probably Monday, Tuesday, I'll kind of just demonstrate some things with Desmos that can kind of help you with it. I'll post the rubric and stuff for your project so you know exactly what you need to do to get your points on it. But basically the assignment is you're gonna try and draw a picture or make a design where you're gonna use all 4 types of conic sections and any other functions you want to kind of help draw your picture. I'll show you some examples from previous years, but it's kind of a cool little project and it's kind of what you make it. I mean, you can make something super complicated, or if you want to make something a little more simple just to hit the boxes on the rubric. I get it. It's kind of what you want to do, but some people made really cool things last year, like someone made Homer, but I'll show you guys those next week. But that'll kind of be our final assignment for this year. So if you got any questions, let me know, but hopefully you guys are all doing well.